Hello, my name is Fatima Perez, and I am a sophomore representing the Solari Academy math team for the freshmen/sophomores. I will be discussing part A of the freshman-sophomore problems. As stated, usually we use the Pythagorean theorem to determine the distance between points in the plane. As such, the distance between the points x1, y1, and x2, y2 is given by the square root of x1 minus x2 squared plus y1 minus y2 squared. However, we can also define the distance between the 2 points using what's called the taxicab distance, which would be given by the absolute value of x1 minus x2 plus the absolute value of y1 minus y2. Part A is asking us to compute the perimeter of the triangle with vertices negative 1, 0, 1, 0, and 0, 2, according to the taxicab distance. I decided to use decimals just to illustrate what the triangle would look like. So this is what it looks like. It's A, B, and C. And to show my work, I used a Jamboard. So here I'm just finding the distance with the formula for the taxicab distance. I found the distance between A and C, C to B, and B to A. So by using the formula here, I just substituted the values into the formula. And from A to C, the distance is 3 units. From C to B, it's 3 units again. And from B to A, it's 2. And given that we found the distance between those points, we can just basically add up the values because it's like adding up the distance from one side to another. So that would be 3 plus 3 plus 2, which is equivalent to 8. So the answer is 8 units. The perimeter of the triangle using the taxicab distance is 8 units. And that's it. Thank you.
Hello, my name is Javier Lobos. I am from Solari's G9G10 team, here to answer part B of the video question. The question itself is: using the taxicab distance, an isosceles right triangle with legs of length 1 can have a hypotenuse of minimum length m and maximum length m. We are supposed to determine both m and n. Alright, so the taxicab method is just x1 minus x, or the absolute value of x1 minus x2 plus the absolute value of y1 minus y2, and it's a way to determine like distance between 2 points. I use decimals to show my work, and we can start off with the most basic scenario, which is this triangle, which has a side length of 1 and a side length of 1, and through the taxicab method this would be equal to 2. But we don't know if that's the maximum or minimum or just one of the possible cases, so we would have to do another case, and this is where this second triangle enters. So we can't use the same method as we did with the last one because it wouldn't make sense. So what we would have to do is that we would actually have to expand off from the origin onto this other point over here, and once we do that, we see that the length of one of the sides is equal to the square root of 2 over 2, so the other one is also equal to the square root of 2 over 2, which means that this side over here, or the distance from the origin to this point over here, would be the square root of 2 over 2, as well as over here. So just to quickly go over what the circle means, what the circle means is that each and every single point on this circle is a point, or well, an end for one of the circles. So that means that no matter what, it's going to, like the length, if the length is equal to 1, both sides I mean, then it's going to end up on this circle. Okay, so we basically already have our answers here because this is the shortest length from the origin to the circle, and this is the longest length from the origin to the circle. So that means that it's all going to be a range. So the range is going to be from the square root of 2 to 2, and that gets us to our final answer, which minuscule m would be equal to the square root of 2, and capital M would be equal to positive 2.
Hi, I am Giovanni Rios, representing Solari Academy for the freshman-sophomore question. I'm going to be doing part C, which goes: describe, with convincing explanation, this set of points in a plane whose taxicab distance to the origin is the same as their Pythagorean distance to the origin. Part 1, you're going to be taking the Pythagorean distance to the origin. Step 1, you're going to be taking the given equation for the Pythagorean distance. Step 2, you're going to be substituting the origin in there. Step 3, we're going to be ignoring those zeros because subtracting by 0 means you're basically doing nothing to the equation. Part 2, we're going to be getting the taxicab distance to the origin. Step 1 is given the equation. Step 2, we're going to be substituting the origin for point 2. Step 3, we're going to be simplifying it. Part 3, we're going to be setting the taxicab distance equal to the Pythagorean distance because, as the question says, they have to be the same. So step 1 and 2, we're just taking in the equations. Step 3, we're setting them equal to each other. And step 4, we're putting all of the information on one side so it's equal to 0. At this point, we have our final equation. What we need to be doing is finding a reasonable domain and range. To find a reasonable domain and range, first we must understand what our equation is actually doing. You can see with the Pythagorean distance part of the equation that we're just getting the hypotenuse. You can see with the taxicab distance part of the equation that we're just getting the legs of a triangle. So when we're looking for the distance between each other, it really doesn't make any sense due to the triangle inequality theorem. Taking this information, we find out that the legs have to sum up to be more than the hypotenuse of the triangle. Taking this information and applying it to our equation means that the taxicab distance, which is equal to the legs, cannot be equal to the hypotenuse, which is equal to the Pythag distance, so the difference of them cannot be equal to 0. Of course, that only applies for places that makes this a triangle, which applies for everywhere else on the Euclidean plane except for the y and x axes. So now we have our domain and range, the x-axis and the y-axis. Now plugging in the y and x-axis for part 4 and part 5, we can see that both of them absolutely work. Now I give you with convincing explanation that the x and y axis are the data points whose taxicab distance to the origin is the same as their Pythagorean distance to the origin. Thank you. Goodbye.